Hello and welcome to today's edition of Cracking the Cryptic, where we're going to take a look at the deadly killer Sudoku from Saturday's edition of the Times. Now, I did suggest we might do the deadly killer Sudoku from yesterday, and indeed I did record the solve of that, but to be honest it didn't feel like a deadly killer Sudoku. It was pretty trivial, and even contained a cage with just one cell in it, or just one number in it, so you could just write it in. So it didn't feel like you know, a puzzle that we necessarily need to vlog about. So I'm hoping that today's is going to be more more challenging. So without further ado, let's load it up and have a look. Okay, and as usual, what I'll do is I'll just I'll fill in some of the obvious ones. So this 16, for example, that can only be 7, 9 when it's a cage of 2 cells, and we should all be able to write in this number straight off the bat. So have a think about how one might do that, and pause the video if you need to. But let's think about the rule of 45. So we know that every 3x3 box contains the numbers 1 to 9 exactly once each. So numbers 1 to 9, if you sum them up, you get 45. Now we've got a cage here which is 17, we've got a cage which is 16, that's 33, and we've got this cage which is 8, so that all sums to 41. So we know that this cage, or this cell here, must be a 4 in order to ensure that this whole box adds to 45. And there's an interesting property now that we can immediately see regarding 12 and 4 cells. Once you've already got a 4 in there, you actually know now that these cells can only be 1, 2 and 5, because we're left with having to make 8 with these 3 cells without using a 4, and the only way that's possible is with 1, 2 and 5. So we can fill those in as well as possibilities, which is helpful. And that of course allows us to just, we've now got a 1 in this box already, so this needs to actually be a 3 in order to make the box work. And just carry on. This has got to be 8, 9, this has got to be 8, 9. The next place I'd probably look now, though it's a little convoluted, it's a good technique to know for these deadly puzzles, is if we were to draw a line across the grid where my cursor's moving here, right along there, we know that every row below this imaginary line would add to 180 in total, because we'd have 4 lots of 45. But we've got lots and lots of cages entirely contained within the rows below this line. So let's sum them and see what we get. So we've got 8, 30, 46, 60, 77, 86, 99, 113, 126, 130, 140, 163. So we know that these 4 cells, in order for those 4 rows to equal 180, have to be equal to 17. These 4 cells here have to sum to 17. Now that is interesting in and of itself, but it is more interesting to think about now, if these 4 cells have to sum to 17, what do these 3 cells have to sum to? And because we know that these 4 cells and these 3 cells are entirely contained within 2 cages, the sum of which is 17 plus 23. Obviously these 3 cells have to sum to 23. And that's really nice, because 3 cells in 23 can only be done one way, and that's with 6, 8, 9. So we can actually use all of that logic to show that as the combination. And that's nice too. We've now got 11 here. We knew that these 4 cells summed 17. So these two cells have to sum to 6 somehow. Why does that matter? Well, it matters because now we can identify the value of this box. 6 plus 10 is 16, plus 23 is 39. So this box must be a 6 in order to make this whole 3 by 3 box add to 45, which means that this is a 7. And the other thing we can immediately note actually is that this 8 cannot contain a 6 and cannot contain a 1, so the only way of making 8 in 2 cells then is 3, 5, like that, which means we've got 1, 2, 4, 7 along here. It can only be 2, 4, 7, 2, 4, 7. This can't contain a 1 because this 8 will have to contain a 1, so that's now all forced, I think. Can't contain a 6 and it can't contain a 9 because we've got a 9 here and a 6 here, so this has to be an 8. This can't contain an 8, and this can't contain an 8. Okay, so this is 1, 2, 5, and this is 1, 2, 5. And that's quite interesting as well, because we can immediately see that if these two cells don't contain a 5, they would sum to 3, which would make this impossible. These could not be big enough. So we know that the 5 is in one of these two positions in column 3, so it's definitely not here. Let's just think a bit further about that. If this was 1 and 5, this would have to be 8 and 9. And if this was 2 and 5, it would actually have to be 7 and 9. So we know that there's a 9 here in one of these two positions. And does that help us to eliminate anything regarding this 10? Very nearly. And in fact, I think we may be able to be certain. Let's just work this through. If this was a 2 and a 5 combination, we've just said that this would have to be a 7 and a 9 combination. Then we would have a 6, a 7, a 9 and a 2 in this box, which would mean there would be no way for this 10 to be completable, because it can only be 4, 6, 3, 7, 2, 8 and 1, 9. So this therefore cannot be the 2, 5 combination, it has to be the 1, 5 combination, which means that this does not contain a 7, and this 3, 7 is the combination here, which is great because that means this is now 2, 4. We said it added to 6, and in fact we could have got that another way, because once we'd locked the 5 in this box, we could have worked out this had to be the 2, 4 variation. Okay, but now that's all looking quite good. This now has to be a 2. So far, I think this is certainly a lot more interesting than the puzzle from yesterday. So that's good. Okay. Now, just scanning the bottom row immediately, we can see we've got quite a lot of cages that are entirely contained within the bottom row. So we can eliminate the value of this to within only 2 things now, because we've got 10, 14 and 14, so that sums to 38. So we know these two cells together sum to 7. But as this can only be a 1 and a 5, this has to be 2, 6. Unluckily, we can't tell which yet. We can say that has to be 7 and 3. And we can say which, because this can't be a 7 because of that. This has to be a 3. This has to be a 6. That's great for this 14 now, because it eliminates the possibility of this 14 being a 6, 8 possibility. This has to now be a 5, 9 possibility. which locks this as a value of 8, which is great. And something just to note here as I'm scanning upwards, we can see that we have 2 5s here and 2 5s here. Therefore, we know that the 5 in this top box here has to be in one of these 3 positions. So it has to either be here, here, or here, but we don't know which one yet. But we'll try and, really we should try and remember that, but I'm going to sort of pencil it in there just as an aide-memoire. So what have we got now? Well, now this has to be 1, 2, 4. In fact, that means this has to be the 1. This has to be 2, 4, 2, 4. These 3 cells add to 7, so this has to be a 6. Okay, 6, 6. Okay. Now, there are very few things that are going to work for this 11. 2, 9 it can't be, 3, 8 it can't be, 4, 7 it could be, and 5, 6 it can't be. So this is a 4, 7 variation of the 11 in 2 cells, which means that this has to be a 2, and this has to be an 8. That locks an 8 down here, and the 8 can't be here because then these 2 cells would have to add to 0, which is not possible. So there is an 8 in one of those 2 cells. And we've also got to place what, a 2 and a 5 along here? Well, that's nice if so, because if this has to contain a 2 or a 5, this whole thing, this whole 8 box has to be the 1, 2, 5 variation of the 8, which means that actually now we can lock the 1 in here, which is nice because that allows us to do this. Okay, 5, 5. Okay. Has to be a 5 or a 9. The reason for that is this 22. 22 in 3 cells has to either be 5, 8, 9 or 6, 7, 9. But obviously we can eliminate several of those possibilities because we already have a 6, 7 and an 8 along here. So this is 2, 5, 9. Some actually this is nice now because this is, oh no, not 2, 5. I've already got 2 here, so in fact this I could have eliminated down further. So this is a 9, and this has to be, what is it, a 3 we're missing, which means this is a 5. So this can't contain a 2. I appreciate that. I hope that you guys appreciate too. As I'm going through this, I'm sort of live solving it, so I'm sure I'm missing some of the obvious entries as we go along, but I hope we can be forgiven for that because I think it's a more interesting experience to watch somebody actually try and solve this, you know, in real time, if you like, making the deductions that we make in the ordinary course rather than sort of doing a pre-prepared solve of it. What do we need now in here? 3, 6, 9 in here, so that's got to be a 6 or a 9, 3 or a 6, 3, 6 or 9 there. Okay, so this cell is seriously limited now. Probably not limited enough to make it worth writing in, but okay. We can see we've got 2 1s here, so by Sudoku logic, one of those 1s has to be there because it can't be in here because of the 13. Okay. I've also got to place a 4 or a 7 here. Yeah, okay. Fortunately, it can't quite eliminate this down yet. can say something else, because we have this 8 now. These 3 cells have to sum to 13 because of this 21 cage. So if these sum to 13 and these 4 cells sum to 20, that's 33 altogether. So these 2 cells have to sum to 12 so that this box adds to 45. But we've seriously limited the ways that can happen. In fact, I think it can only happen if that's a 5 and that's a 7. I think that's the only option left, which would mean that actually we can do a whole load of things here. Wow, look at this. It's that certainly helped. Now we've got these 2 adding to 9, so these 2 have to add to 11, so this can't be a 1, and this has to be a 1. That. And now these 3 sum to 12, so this has to be an 8. 8. It looks like that was the key logical step to really break this puzzle open. So we can't have an 8 here or here. So this has to be a 2 or a 4. Well, it can only be a 2 and make this sum work. So this is a 4 and this is a 2. Okay. That's got to be a 6. That's got to be a 3. Right. These 2 cells have to sum to 9. Well, the only way that can happen is if these are 4, 5, because that's the only 9 option left now. Which means this is a 4 and this is a 7. Which means this is a 7, I think. These 2 have to sum to 12, so this is 3, 9. Oh, sure. To do that, 3, 9, 3, 9, like this. This is a 7. And this is a 9. Okay, so we're really starting to make progress now. Somewhat surprising that we can't limit the options for this 8. It could still, I think, be 2, 6 or 3, 5 at this point, which is, as I say, it's a little surprising. Oh no, it can't, because we've already got a 5 and a 5 here and here. So this is in fact a 3, 5 variation of the 8, which means that this is a 9. This is a 3. We're going to put a 9 here or here, but we don't know where. I'm going to note it just for sake of good order, and we need to put a 2 and a 6 into these cells. Okay, well that can only be done like this. Ah, and that's nice, because now these 2 sum to 3, therefore this has to be 8 and 9, and we know that the 9 has to be either here or here, so it can only be here. So this is a 9 and this is an 8. And we're left with having to put 3, 4 in the box, so hopefully this 21 will work. Yeah, it does, so that's looking good. This is a 3, this is a 5, this is a 2, this is a 4, and this is a 9, this is a 5. Okay, you can see this has to be 1, 2, 1, 2, and this has to be, is it 6, 8? And you can see that because everything is boxed here, we need a vertical sum in order to resolve this. And where are the vertical sums? Well, they're only in these 2 positions. So we can be pretty certain that this is going to be really limited. Let's just check that. Well, okay, let's make this a 9. You can see we can't make 8 from these 2 cells, so this is a 6. And this is a 9, and that probably finishes the puzzle. Yeah, here we go. 6, 9. So if this is a 6, these have to sum to 11. That's forced to be a 7 and a 4 and a 4, 2, and a 2, and 1. Apologies for that. I keep having to go backwards and forwards. It's just the way the software works. And there you go, the Deadly Killer cracked on Saturday. I hope this was educational. and we'll see you again next time on Cracking the Cryptic.